हाय फ्रेंड्स, वेलकम टू माय यूट्यूब चैनल फिजिक्स एक्सप्रेस। बार्क मेमोरी बेस्ड सॉल्यूशन का सीरीज़ कंप्लीट हो चुका है। आप प्लेलिस्ट में विजिट करके देख सकते हैं। अप्रोक्स 40 अराउंड क्वेश्चन में कर चुका हूँ वहाँ सॉल्व। नाउ वी हैव टू स्टार्ट अ न्यू सीरीज, टॉप 5 क्वेश्चन सीरीज ऑफ क्वांटम मैकेनिक्स। Today I have taken 5 special questions from quantum mechanics from TIFR exam, which is very important questions for exams like CSIR NET and GATE. Here is the first question. A particle is initially in its ground state in a one-dimensional harmonic oscillator potential V of x equal to half kx square. If the spring constant is suddenly increased 4 times, then calculate the probability of finding the particle in the ground state of the new potential. For solving this type of question, we have to first write the wave function of the old state. Then we have to write the wave function for increased spring constant case. Then we normally do the process of finding the probability, but that process is quite lengthy, so we have to follow a trick. First you have to pause this and solve the question, then you should see the answer. So move to the answer. The trick is, if omega changes to n omega, then this is the value of the probability of ground state. Okay, so we have given k prime k prime increased 4 times, means k prime changes to 4k. We have to change it from k to omega first, then we can solve, or we can apply this trick. We know k equal to m omega square, so omega equal to under root k upon m. Then we should find omega prime as k prime upon m under root. Then put the value of k prime, that is 4k, and from this we get the omega prime value as 2 omega. Then compare this with omega prime equal to n omega, so n equal to 2 here. Here we can apply the trick and find the probability of the new state. This is 2 upon root 2 plus 1 by root 2, and after solving we can get it as 0.94, and this is the answer. Then move to the next question. This is a very important question. A particle of energy E move in 1D under the influence of potential V, E greater than V given for some range of x, which graph represent bound state wave function of the particles. We know very well, if E is greater than V, then the nature of the wave function is oscillatory. Let us analyze the options. This is not oscillatory graph, this is also not oscillatory graph. Only two oscillator graphs are given, this and this. This wave function cannot be acceptable because for the value of 0 here two values are exist, so this is not a acceptable wave function. For this, wave function should be vanish at the boundaries, means at plus minus infinity, but this graph does not vanish at plus minus infinity, so this cannot be the wave function. Now come to option B. This is oscillatory function, but this could not be our answer because this wave function is not vanishing at boundaries. You can see clearly. Now come to the last option. Technically this is the best option. Let us analyze this. This function is continuous. Its first derivative is also continuous. This graph is square integrable. Psi vanishes at plus minus infinity. Here you can see minus infinity, here plus infinity, and the wave function is going to vanish here. And this function is single valued, so this is the best answer. Then move to the next question. A particle is in the ground state of cubical box of side L. Suddenly one side of the box changed to 4L. If P is the probability of finding the particle in the ground state of new box, then find 1000 P. This wording is important. Here it is given suddenly. Suddenly change means it is an adiabatic change. And in adiabatic change, the particle remains in the ground state, but the limit will not change. The width will change to 4L, but the limit will remain same as 0 to L. Let us solve this question. This is the wave function of particle in a cubical box. Under root 2 upon L sin pi x by L, under root 2 upon L sin pi y by L, under root 2 by L sin pi z by L, because it is given in 3 dimension. Then multiply this, multiply the constant term, 8 upon 2 L cube under root sin pi x upon L sin pi y upon L sin pi z upon L. Probability, this is the probability formula. Phi is the new state, psi is the older state, and expectation value of phi, psi and mod square is the required probability. Then calculate this. Integration upon 0 to L, limit 0 to L, because the change is adiabatic. Then we have to perform the integration. Only one side is changing. Let us assume the side changing side is x side. So sin x upon 4L here, and this will remain same as L. Then perform the integration. 0 to L sin square pi y upon L, 0 to L sin square pi z upon L. Those two values are L by 2. Then perform the integration. We get the value as 8 root 2 upon 15 pi. Then putting the values, we get this expectation value as 0.24. But we have to find the probability. So probability is the square of 0.24 and it is 0.0576. This is the required probability. We have to answer in terms of 1000 P. So just multiply the P by 1000 and the answer is 57.6. I hope you will understand. Then move to the next question. First, you should pause the video and solve the question. If you are not getting the answer, then you should look into the solution. The question is, a fermion of mass m moving in 2 dimensions is strictly confined in a square box of side L. The potential inside is 0. A measurement of the energy of fermion yield the result E equal to 65 pi square h cut square upon 2 ml square. The degeneracy of the energy is. This is a very important question. The degeneracy related question asked in almost every exams. How we can approach this? The general value of energy for the 2-dimensional square box is E equal to nx square plus ny square pi square h cut square upon 2 ml square. Then comparing the values, we will get nx square plus ny square equal to 65. Then we should find the combinations, various combinations for which nx square plus ny square must be 65. The values are, one is 81187447. These 4 combinations will give the value nx square plus ny square equal to 65. So in option 4 is there, but if we take the 4 answer, option B, it is not the correct answer, because here fermion is given. In fermion there is spin part also included. Fermion is a spin half particle, so we have to include the role of spin also here. So for considering spin, the degeneracy becomes double. So 2 into 4, 8 degenerate states. So 8 is the correct answer. Then move to the next question and 5th question of the day. two harmonic oscillators A and B in excited energy states and with same excitation energy E as measured from their respective ground state energy. The natural frequency of A is twice that of B. If wave function of B is given in the picture, which is the best wave function of A? Two harmonic oscillators are given, their energy same given, but the natural frequency of A twice that of B given. This is the wave function of B and we have to find the wave function of A. जब भी हार्मोनिक ऑसिलेटर का केस आता है तब हमें नोड्स पे कंसीडर करना चाहिए. ग्राउंड स्टेट एनर्जी फॉर ग्राउंड स्टेट एनर्जी ऑफ हार्मोनिक ऑसिलेटर the energy is n plus half h cot omega. For ground state n equal to 0 and the ground state wave function graph is like this type. This is the ground state energy. Here no nodes are present, so for n equal to 0 node also 0. Similarly for n equal to 1 node equal to 1, for n equal to 2 node equal to 2. So the number of nodes is equal to the number of n. Here we will count the number of nodes. 1 2 3 4 5 6 7 8 9 10. 10 nodes are here. So n equal to 10 for B. N equal to 10. We have given EA equal to EB, energy same. EA, the value of EA is NA plus half h cot omega A and value of EB is NB plus half h cot omega B. We have given that omega A equal to 2 omega B. Let us substitute the value. Instead of omega A, we will put the value 2 omega B from this. Then after solving, we will get 2NA plus 1 equal to NB. Here the NB value is 10, so 10 plus half h cot omega, so it is 10.5. 2NA plus 1 equal to 10.5. From this we found NA equal to 4.75, approximately 5. Then we should check the option. NA equal to 5 means the number of nodes present in the wave function of A should be 5. Let us move to the option. 1 2 3 4 5. Here 5 nodes are present, but this is not our answer because in option it is starting from -5 to +5, but here it is starting from -10 to +10, so it cannot be our answer. Here number of nodes are more than 5, so this cannot be our answer. Here number of nodes are 1 2 3 4 5 6 7, more than 5, so also this is the wrong option. So the remaining option is our answer. This is option B. You can count also the number of nodes 1 2 3 4 and 5. So this is the perfect answer. Okay, this is the last question of the day. Tomorrow I will upload some more questions of different topics. अगर आपको ये वीडियो अच्छा लगा हो तो आप चैनल को सब्सक्राइब कर दीजिए और फर्दर नोटिफिकेशन प्लीज़ प्रेस द बेल आइकन. प्लीज़ चैनल को सब्सक्राइब कर देना क्योंकि आप लोग वीडियो देख के चले जाते हो, सब्सक्राइब नहीं करते हो. बिल्कुल फ्री है सब्सक्रिप्शन, सो सब्सक्राइब कर दो प्लीज़. सी यू इन द नेक्स्ट वीडियो. टिल देन बाय बाय.